Welcome to No Zero Multiplication Part 2. I'm Matthew Tambaya, the creator of Fast Math. This video goes into more detail on the concepts behind no zero multiplication. This is a follow-up video to my first set of videos on no zero multiplication, which you should definitely watch before watching this video. Links are below. As a review, let's say we want to do the calculation 60 million times 3,000 mentally. Most people need pen and paper to do this calculation, but in business, it's really advantageous to be able to do this calculation mentally. You frequently need to calculate revenue and profit and make decisions based on numerical results. Most people need pen and paper to perform this calculation because they need to write out all the zeros and count them. Write down the result and then count the zeros in the result to determine what the numerical value is. And that's very difficult to do mentally for most people. As another example, try to calculate 800 million plus 400 million mentally. Most people say they need to see it or write out the numbers with the zeros to calculate the answer. What is your answer? How would you say the result out loud and how would you write the number? Again, the calculation is 800 million plus 400 million. And I'm not showing the numbers, so you need to do the entire calculation mentally. Go ahead and write down your answer and we'll come back to it later. Also, what is 1.4 billion minus 600 million? Do this calculation mentally and write down the answer. Now I'll review the fast math method to calculate the answer to this multiplication calculation. I started teaching this method in 2013 at leading business schools like Wharton and Harvard, and I also published an online course with this method. We write the calculation using the abbreviations M for million and K for thousand. These values are called units of magnitude. So the calculation becomes 60M times 3K. K is short for kilo or 1,000. Next, we multiply the numerical portions. 3 times 60 is 180. Next, what is a million times 1,000 or M times K? A million times 1,000 is a billion, which we abbreviate with B. Again, a billion is 1,000 millions. And we just combine these two pieces to get the answer of 180 billion. As I like to say, look, Mom, no counting zeros. This method is called no zero multiplication because we don't count the zeros. The central idea is that we can multiply the numerical portions and the units of magnitude separately and combine the results. You just need to learn how to multiply the units, which is relatively easy. If you write this calculation with all the zeros, you'd have this. Most people calculate this by multiplying 6 and 3, which are the leading terms, and counting all the zeros. 6 times 3 is 18. Counting zeros, we have 7 in 60 million and 3 in 3,000 for a total of 10 zeros. So the result is 18 with 10 trailing zeros. What's this number? If you write it out, you get this. But even interpreting this result visually is difficult, and you still have to count the zeros to determine the value. In the US and England, we write a comma to group 3 digits, which also separates the units of magnitude. So most people need to write the commas to interpret the number. Commas go here, here, and here. Interpreting this number, you have 180 billion, just like we found with no zero multiplication. These are thousands, these are millions, and these are billions. Again, most people need pen and paper to do this calculation. Compared to written calculations with counting zeros, no zero multiplication has several advantages. 1, it gives the answer incredibly quickly. 2, we can perform no zero multiplication mentally, so we don't need pen and paper or a calculator, which is really helpful in business. 3, it gives the answer in a format we can easily interpret by giving the unit of magnitude directly, so we don't need to count zeros in the result. And 4 is much simpler no zero multiplication is much simpler and more intuitive than counting zeros. Once you learn no zero multiplication, you can do these calculations mentally without relying on pen and paper or a calculator. This is a game changer. Again, even with pen and paper or a calculator, interpreting a number like this result can be difficult for a lot of people. Another example, 30 million times 8,000. Using abbreviations, this is 30M times 8K. Multiplying numerical portions, 30 times 8 is 240. Multiplying units of magnitude, million times 1,000 is. We learned before that million times 1,000 is a billion. So we just combine these two pieces and the answer is 240 billion. It's that simple. Again, this method is called no zero multiplication because there's no counting zeros. To review, we define these units of magnitude with unit abbreviation, unit name, and unit value. Thousand, million, billion, and trillion. K is the abbreviation for thousand, which is 10 to the third. And each abbreviation is the first letter of the unit name, except K is the abbreviation for thousand, and K comes from kilo, which means thousand in the metric system. We use T for trillion, so we need to use another letter for thousand. The power of 10 exponents are 3, 6, 9, and 12. Notice that the exponent of 10 increases by 3 with each larger unit. This means that there is a fixed ratio between unit values of 10 to the third, which is 1,000, and which we abbreviate with K, which is called the unit ratio. Meaning each value is 1,000 or K or 10 to the third times the prior unit value. And this follows from the exponent addition property, which says that when you multiply numbers with the same base, in this case the base is 10, you add the exponents. So 10 to the third times 10 to the third equals 10 to the sixth. This means that multiplying a unit by 1,000, which is 10 to the third, and which we abbreviate with K, increases the exponent by 3, which takes you to the next larger unit. So starting at 1,000, which is 10 to the third, and multiplying by 10 to the third, which is 1,000 or K, you increase the exponent by 3, going from 3 to 6, to get 10 to the sixth, which is 1,000,000. Using abbreviations, K times K equals M. 10 to the third, which is K, times 10 to the third, which is K, equals 10 to the sixth, which is M, or million. Similarly, multiplying 1,000,000 by 1,000 increases the exponent of 10 by 3 from 6 to 9, and takes you to the next larger unit from million, which is billion. Using abbreviations, K times M equals B, or 1,000 times million equals billion. And multiplying 1,000,000,000 by 1,000 increases the exponent of 10 by 3 from 9 to 12, which takes you to the next larger unit from billion, which is trillion. Using abbreviations, K times B equals T, or 1,000 times billion equals trillion. To explain, because the exponent of 10 increases by 3 with each larger unit, each unit value is 10 to the third, or 1,000, or K times the value of the next smaller unit. These equations just express this fact using the unit abbreviations in place of the scientific notation. When I read an equation with unit abbreviations like this out loud, I will generally say the full unit name rather than the abbreviation. So I would read this out loud as 1,000 times million equals billion. To summarize, the main ideas are that first, K is the abbreviation for 1,000 or 10 to the third, so get used to seeing K in fast math resources. Next, multiplying a unit by 1,000 or K or 10 to the third gives you the next larger unit, which I call promoting the unit. So just learn the sequence of units, K, M, B, T, 1,000, million, billion, trillion. These are the 3 key unit multiplication facts, so there aren't that many to learn. Again, just learn the order or sequence of units, and that multiplying a unit by 1,000 gives you the next larger unit. Even just the first 2 facts will provide a lot of value. You should be able to learn these. 1,000 times 1,000 equals million, and 1,000 times million equals billion. I have a 2-hour online workshop that teaches you a method to master no zero multiplication and no zero division. So sign up for the 2-hour workshop if you want to practice no zero multiplication more. Link is below. This is a review of the prior videos. Now we'll go a little deeper. The first thing I want to point out is that the original definitions of these units of magnitude, meaning the words 1,000, million, billion, and trillion, weren't in scientific notation, which uses powers of 10. For example, million wasn't originally defined as 10 to the sixth. These words are hundreds of years old. Scientific notation was only used widely beginning in the 1900s. The original definitions of these units of magnitude also didn't have an abbreviation associated with them. Unit abbreviations are also relatively recent. The original definition of 1,000 was that it was 10 hundredths. We're going to write 1,000 as 1,000 times 1. You'll see why soon. Again, we're using the abbreviation of K for 1,000, so we can write 1,000 as K times 1 or K to the first. How was million originally defined? Again, think about how million was defined without scientific notation. The original definition of 1 million was 1,000 thousands, or 1,000 times 1,000. I won't write this out in long form format, so million wasn't originally defined as 10 to the 6th. We can represent million as 1,000 times k. Here I'm writing million as 1,000 in long form of the next smaller unit of magnitude using the abbreviation for the smaller unit. Using all unit abbreviations, million is k times k, or 1,000 times 1,000, which is 1,000 squared, or k squared. Again, the abbreviation for million is m. So these are different ways to express the value of million. How was billion originally defined? The original definition of a billion was 1,000 millions, or 1,000 times million. I won't write this out in long form format. We can represent billion as 1,000 times m, or 1,000 millions. Using all unit abbreviations, billion is k times m, and because million is 1,000 squared, or k squared, k times m is then k to the third. So billion is 1,000 to the third, or k to the third. The abbreviation for billion is b, so these are different ways to express the value of billion, or b. The original definition of 1 trillion was 1,000 billions, or 1,000 times 1 billion. We can represent trillion as 1,000 times b. Using all unit abbreviations, trillion is k times b. Because billion is k to the third, k times b is then k to the fourth. So trillion is 1,000 to the fourth, or k to the fourth. And the abbreviation for trillion is t. So these are different ways to express the value of trillion, or t. Because the exponent of k is increasing by 1 with each larger unit, each unit value is 1,000, or k, times the next smaller, or previous unit value. In general, next unit means the next larger unit, and previous unit means the next smaller unit. So here are patterns in how this table is arranged. This column expresses the unit value as 1,000 of the next smaller unit of magnitude, with 1,000 written in long form format, and using the unit abbreviation for the next smaller unit. So here million is expressed as 1,000 thousandths, billion is expressed as 1,000 millions, and trillion is expressed as 1,000 billions. So 1,000 is fixed, and the unit is the next smaller unit of magnitude. This column represents the unit value using unit abbreviations of k times the next smaller unit of magnitude. Here k, or 1,000, is fixed and appears in each row. And this column expresses the unit value as a power of 1,000, or a power of k. Note that 1,000 is the only unit of magnitude that we write in long form format. We generally won't write million or larger numbers using long form format. We just use the abbreviation. Putting each way of expressing the unit value into a separate column, we have this. These are all different ways of expressing the same information based on how we represent 1,000. Each unit value is 1,000, or k, times the next smaller unit value. There is one more way to write these values. We can express these unit values as powers of 1,000 written in long form. So the main point is that each unit value is 1,000, or k, times the next smaller unit value, which makes each unit value a power of 1,000, or a power of k, with the exponent of 1,000 starting at 1 and increasing by 1 with each successively larger unit. Using the definition that k equals 1,000, the definitions in each row are all equivalent. If you define these unit values in this way and then express 1,000 as 10 to the third, you also get the values in scientific notation, which are these values: 10 to the third, 6th, 9th, and 12th power. The main point is that these unit values were originally defined as 1,000 of the next smaller unit value, which makes them powers of 1,000, or powers of k. Defining k as 1,000, or 10 to the third, and using these definitions of the unit values, we can express these unit values in scientific notation with a base 10 exponent, as shown here in this column. Again, these definitions are all equivalent. These are all different ways of expressing the same information. These aren't the only ways to express the unit values. I have several other ways in my free course. This may appear complex, but we can simplify things. The simplest way I could think of to express this information is to represent the unit values as whole number powers of k, or 1,000, with the exponent starting at 1 and increasing by 1 with each larger unit value. The exponent of 1,000 just goes from 1 to 4. And with the definition that k equals 1,000, all the other facts can be derived from this information here. So look at this table as long as you need to so that the pattern's in sync. The exponent starts at 1 and just increases by 1 with each larger unit value, going from 1 to 4. To learn no-zero multiplication, I recommend learning the unit sequence, KMBT, use the mnemonic, kick my big toe, and multiplying a unit by 1,000 just promotes the unit to the next larger unit. Here we have the unit abbreviations, and here we have the unit names and abbreviations. Study this as long as you need to. And these are the two most important unit multiplication facts. 1,000 times 1,000 equals million, and 1,000 times million equals billion. We have a few more unit multiplication facts. 1,000 times billion equals trillion. And finally, what is a million times a million? It's a trillion. So these are the key facts for no-zero multiplication. Now I have a few more examples I want to show you. First example, what is 3,000 times 4,000? This is meant to be simple. 3 times 4 is 12. And what's 1,000 times 1,000? 1,000 times 1,000 is million. So the result is 12 million. Again, no counting zeros. Next example, what is 3,000 times 6 million? 3 times 6 is 18. And what's 1,000 times a million? That's a billion, or B. So the result is 18 billion. Next example, what is 2,000 times 8 billion? 2 times 8 is 16. What's 1,000 times billion? What's the next larger unit than billion? 1,000 times billion is trillion, or T. That is, a trillion is 1,000 billions. So the result is simply 16 billion. Those are the basics of no-zero multiplication. Next, what is 420 million times 1,000? 3, 2, 1. If you're still trying to figure out what the answer is, you haven't fully understood no-zero multiplication. Multiplying a number by 1,000 just promotes the unit of magnitude to the next larger unit while keeping the numerical portion the same. The unit bigger than million is billion. So the answer is 420 billion. We just change million to billion or change M to B. That's it. You don't need to count zeros, just promote million to billion, and the numerical portion of 420 stays the same. This is a direct result of the fixed unit ratio of 1,000 between unit values. 1,000 millions is a billion. Next example. What is 800 million plus 400 million? Try to do this calculation mentally. How would you write the answer, and how would you say the answer? Again, most people need pen and paper to perform this calculation, including a lot of people who work in business or even at business schools. But if you work in business, you should be able to do this calculation mentally. Visually, we can represent this calculation like this. Adding these, the result is 1,200 million. If you add two numbers with the same unit of magnitude, you simply add the numerical portions and keep the same unit of magnitude. 800 plus 400 is 1,200. The unit stays at million. But most people wouldn't say this number as 1,200 million. Have you ever heard somebody say 1,200 million? It sounds awkward. So how would you say this number? How do you think a business person would say this number? 1,200 million also doesn't sound right. Since we have over 1,000 millions, a business person would express this number with the next larger unit of magnitude, which is billion. So how would we express this number in billions? Think about this for a few seconds. Answer in 3, 2, 1. This is 1.2 billion. How do we get this? We get 1.2 by dividing 1,200 by 1,000. This handles the numerical portion. At the same time, we promote the unit of magnitude from million to billion. Mathematically, we can think of this as multiplying 1,200 million by k over 1,000, which is 1 because k equals 1,000. We divide the numerical portion by 1,000 and multiply the unit of magnitude by k, which is also 1,000, which promotes the unit from million to the next larger unit of billion. Dividing 1,200 by 1,000 moves the decimal point from here, where it's unwritten, to here. So 1200 becomes 1.2. This gives us the general principle that the numerical portion of a number should be between 1 and 1,000 and always less than 1,000. If the numerical portion of a calculation result is greater than 1,000, we need to resize the unit or grow the unit. So this means we need to grow the unit here and resize the number from 1,200 million to 1.2 billion. This is how business people would say the number. You've probably heard people say 1.2 billion or 1.2 million. You wouldn't normally hear business people say 1,200 million. Business people also wouldn't say 1,200 million, even though this is likely how many elementary school teachers instruct students to say the number. Business people who understand numerical values would say 1.2 billion, including consultants at McKinsey and business school students at MIT and Harvard. In calculations, I would write this as 1.2b. Now, there are lots of ways to write this numerical value. In paragraph text, I would just write this as 1.2 billion using the unit name. In calculations and charts and tables, I would write the unit abbreviation B. There is variation in how people express this number. Many sources don't use long-form format, but use some form of an abbreviation or unit name. Many newspapers in the US would write this number using the unit name with a lowercase b, as in billion. Some people use an abbreviation with different formatting. For example, some people use a capital B without a space between the numerical portion and the unit magnitude, and some people use a space between the numerical portion and the unit magnitude. I've seen entities use a lowercase b, both with and without a space. And some people might use another abbreviation for billion, such as BLN, either with or without a space. I've seen all of these variations in newspaper and corporate literature. I would read or say all of these as 1.2 billion. Again, FastMath uses a capital letter for the unit abbreviation. And for calculations, FastMath uses a space between the numerical portion and the unit abbreviation, which is what I think is easiest for readability. And this is what I recommend for calculations. But there is variation in all of these, and these aren't the only variations I've seen. I've seen other abbreviations and notation for representing large numbers in business. My free course has a style guide with recommendations and best practices for how to use unit abbreviations and write large numbers in different contexts. The style guide has a more detailed discussion of the different options and formats for writing large numbers using units of magnitude. So look at the style guide if you want to go into this topic in more detail. The main point is that there is variation in how people write large numbers using unit abbreviations and unit names. No zero multiplication can be used with any of them, as the unit multiplication facts remain the same. Many people that use a single letter for these unit abbreviations use the same abbreviations that FastMath uses: K, M, B, and T. In particular, these abbreviations are what are primarily being used in the management consulting industry. As noted, some entities use entirely different abbreviations and conventions for expressing large numbers. These abbreviations are what FastMath uses, and this is what I recommend, and this is what's catching on in the management consulting industry. Next point. All these variations exist and more for all of the abbreviations. So you may see all of these variations with M for million in place of B for billion. Different entities will write the abbreviation M for million in different ways. Some use uppercase and some use lowercase. Some use a space and some do not. And some use MLN, both with and without spaces. And some entities write the full unit name million. And entities may use similar variations with T for trillion and with K for thousand. And each of these abbreviations are used with both upper and lowercase, and both with and without spaces, and with abbreviations that are multiple letters, like MLN for million. Generally, a given entity will have consistent formatting for the abbreviations. So if they use a lowercase b for billion without a space, they will also generally use a lowercase k, m, and t, also without spaces. The point is that different entities use different formatting, and if you want to read and understand these values, you need to recognize what they mean and understand that these are different ways of expressing the same things. And by entity, I mean a company or a newspaper or somebody writing something that uses these unit abbreviations to express numerical values. Each formatting variation may be useful in certain contexts and has its own strengths and weaknesses. Again, the Fast Math course, Fast Mental Math for Business, has a style guide that discusses different formatting options. Next example, what is 300 million times 6? Well, we can operate only on the numerical portion. 300 times 6 is 1800, so the answer is 1800 million. But we generally wouldn't represent the number like this. We would express the answer in billions, and this is 1.8 billion. The point is that we may need to resize the unit after addition or after multiplication if the numerical portion of the result exceeds 1000. You'll definitely want to practice resizing units, and I have practice problems with detailed explanations in the 2-hour no-zero multiplication and division workshop. Like the previous example, we divide the numerical portion of 1800 by 1000 to get 1.8 and promote million to billion. Next example, what is 2 billion divided by 10? Think about this for a few seconds. Can you do this calculation mentally? How would you write and say this number? Again, if you work in business, you'll want to be able to do this calculation mentally. If you want to operate on the numerical portion of 2 billion, this may cause confusion because 10 is bigger than 2. So the result will be less than 1 billion. So it's natural to resize the units. Each billion is 1,000 millions. So 2 billion is 2,000 millions. I call this breaking the unit, which means to express a given number with units of magnitude in terms of the next smaller unit of magnitude. We break each billion into 1,000 millions. And we do this by multiplying the numerical portion of 2 by 1,000 to get 2,000 and demoting the unit of magnitude from billion to the next smaller unit of million. And we can think of this as multiplying 2 billion by 1,000 over k, which is equivalent to multiplying by 1 since k equals 1,000. Multiplying by 1,000 changes the numerical portion from 2 to 2,000, and dividing by k demotes the unit from billion to million. We can also think of this as substituting in 1,000 million or 1,000 m for each billion. Once we write it like this, we can easily divide the numerical portion of 2,000 by 10, which cancels a 0. So we are left with 200 million. So the point is that you may need to break the unit of magnitude when dividing numbers. Next example, what is 1.4 billion minus 600 million? Try to do this mentally. How would you write the answer and how would you say the answer? Again, if you work in business, you'll want to be able to do this calculation mentally. This is the calculation in written form. Now, as written, we can't just subtract the numerical portions because the units of magnitude are different. This is in billions and this is in millions, so we need to put them in the same unit of magnitude. Can you figure out the answer? Breaking 1.4 billion into millions, we have 1,400 million, from which we are subtracting 600 million. So the result is 800 million. We just take 1,400, subtract 600, and keep the unit of million because these two are the same unit of magnitude. And again, the result is 800 million. And this is how a business person would say this number. The numerical portion of the result is between 1 and 1,000, and people generally wouldn't express this result in billions. So the point here is that you need to resize units to add and subtract numbers with different units of magnitude. Once they have the same unit of magnitude, you can just add and subtract the numerical portions. Next example, what is 2 billion minus 300 million? Try to do this mentally. How would you write the answer and how would you say the answer? Again, if you work in business, you'll want to be able to do this calculation mentally. This is the calculation in written form. Now, as written, we can't just subtract the numerical portions because the units of magnitude are different. This is billion, this is million. So what should we do? Pause the video and think about it. Solution in 3, 2, 1. For this problem, we want to express 300 million in billions, or resize the unit from million to billion. 300 million is 0.3 billion. So we have 2 billion minus 0.3 billion, which is 1.7 billion. This is how a business person would say this number. The numerical portion is between 1 and 1,000. If you express this number in millions, it's not how business people would usually express this number. If you broke 2 billion into 2,000 million and then subtracted 300 million to get 1,700 million, you would want to resize this result to 1.7 billion. So for this problem, we resize 300 million to 0.3 billion because the result would be in billions. The point here is that to add and subtract numbers with different units of magnitude, you need to resize the units to the same unit of magnitude, and then add or subtract the numerical portions. Here are some facts to help you resize units. The main point is that tenths of units are hundreds of the next smaller unit. 1 billion divided by 10 is 0.1 billion, which is 100 million. You'll get this result because 1 billion is 1,000 million. So if you divide 1,000 million by 10, you get 100 million. 1 million divided by 10 is 0.1 million, which is 100,000. 1,000 divided by 10 is 0.1 thousand, which is 100. And 1 trillion divided by 10 is 0.1 trillion, which is 100 billion. These are some of the basic operations for resizing units of magnitude or breaking units. Here are the facts without the tenths of billions. 1 billion divided by 10 is 100 million. 1 million divided by 10 is 100,000. 1,000 divided by 10 is 100. And 1 trillion divided by 10 is 100 billion. Look at this as long as you need to understand the pattern. Again, a tenth of a given unit is 100 of the next smaller unit. Here are some additional facts for resizing units. The point here is that hundredths of a unit are tens of the next smaller unit. 1 billion divided by 100 is 0.01 billion, which is 10 million. 1 million divided by 100 is 0.01 million, which is 10,000. 1,000 divided by 100 is 0.01 thousand, which is 10. And 1 trillion divided by 100 is 0.01 trillion, which is 10 billion. So 1/100th of a unit is equal to 10 of the next smaller unit of magnitude. And again, we can think of 1 trillion as 1,000 billions. So dividing 1,000 by 100, you get 10. These are the facts for breaking units. Here are the same facts without the middle column. 1 billion divided by 100 is 10 million. 1 million divided by 100 is 10,000. 1,000 divided by 100 is 10. And 1 trillion divided by 100 is 10 billion. Another important point is that no zero multiplication gives the same answer as long-form format calculations. Let's consider the example 60 million times 3,000. Using long-form format, we have this. This is 60 million, this is 3,000. Traditional math generally tells students to multiply the leading terms, which are 6 and 3, and then count the zeros in the original multiplication terms. There are 7 zeros in 60 million, and 3 here, for a total of 10, and then append this number of zeros to the first result. 18 with 10 zeros looks like this. We have comma separators every 3 digits, and these actually separate the units of magnitude. The first 3 digits are ones, tens, and hundreds, and each group of 3 digits afterwards, moving from right to left, represents ones, tens, and hundreds for a given unit of magnitude, like thousand, million, and billion. These next 3 digits are ones, tens, and hundreds of thousands. The next 3 digits are ones, tens, and hundreds of millions. And the next 3 digits are ones, tens, and hundreds of billions. So this result is 180 billion. And this is the long form format of the result. We can write this result using the abbreviation B for billion as 180B and using the unit name, 180 billion with billion written out. Again, these are 3 different ways to express the same number. Now it can take time to visually interpret the long form result as 180 billion. We can also use no zero multiplication to calculate the answer. In no zero format, this calculation is 60m times 3k, or 60 million times 3,000. 60 times 3 is 180, and million times 1,000 is billion. So the answer is 180 billion. So no zero multiplication gives the exact same result in the unit of magnitude without needing to count zeros in the original multiplication terms or in the written answer. And no zero multiplication is something we can do mentally very easily. Instead of counting all the zeros, no zero calculation stores the place value of the digits after the first comma in the unit abbreviation, such as M for million or B for billion. With this example, the abbreviation M for million stores the information of the 6 zeros from 60 million. The abbreviation K for thousand stores the information of 3 zeros from 3,000. And the abbreviation B for billion stores the information of 9 zeros from the result. We keep a 0 or power of 10 in the numerical portion of 60. No zero format is just a simple and intuitive way to store place value information. So again, no zero calculations provide the same answer as long form calculations. One advantage of no zero multiplication is that it's much easier to read or interpret this result with the abbreviation, so 180b, compared to the long form result, which is 18 followed by 10 zeros. Again, you have to count these zeros. Another way to understand no-zero multiplication and see that it gives the same answer as long-form format calculations is if we multiply a number by 1,000. In this example, let's take 63 million times 1,000. In long-form format, we have this, 63 with 6 zeros. Now, multiplying by 1,000 will append 3 zeros to the long-form format of 63 million. Append means to add at the end. Now I'm going to append 3 zeros. Now we need to interpret this result. Again, the first 3 digits from the right are ones, tens, and hundreds. The next 3 digits are ones, tens, and hundreds of thousands. The next 3 digits are ones, tens, and hundreds of millions. And the next 3 digits are ones, tens, and hundreds of billions. So this result is 63 billion, which we can write with the abbreviation 63B. As you can see, the numerical portion of the result is the same as the numerical portion of the original value of 63 million. The unit of magnitude simply changed from million to billion, or from M to B. This occurs because multiplying by 1,000 appends 3 zeros, which are separated by a comma, which correspond to the leading digits moving to the next larger unit of magnitude. That is, doing so keeps the 6 and the 3, or whatever digits may be there, in the same relative position to the comma, but we have appended another block or group of 3 zeros, which corresponds to the digits moving from million to billion or to the next larger unit of magnitude. And this occurs when you multiply any number by 1,000. The result will have the same numerical portion, with the unit of magnitude simply changed to the next larger unit of magnitude, which we call promoting the unit of magnitude. So to summarize, to multiply by 1,000, just promote the unit of magnitude to the next larger unit and keep the numerical portion the same. I will illustrate this calculation with no-zero multiplication. This becomes 63m times 1k, and 63 times 1 is 63, and million times thousand is billion, so the result is 63 billion. Again, the unit is simply promoted from million to billion. And notice that since we're multiplying by 1,000 or 1k, the numerical portion is the same. Whatever the original numerical portion is gets multiplied by 1, so it stays the same. Another way we can streamline this calculation is, since we're multiplying by 1,000, we don't actually have to explicitly write the 1 in 1,000. And we don't have to actually do anything in this line. We can just remember that the numerical portion stays the same. And we can essentially just keep k here. Here are the corresponding steps: 63m, or 63 million, times k, or 1,000. We don't write the 1. We just do the unit multiplication of million times thousand is billion. And the numerical portion stays the same, and so we have 63 billion. And furthermore, once you learn no-zero multiplication, you don't need to write out the step of million times thousand equals billion. You can just write down the result of 63 billion. And I include this step for now for people who are learning so they can visualize and understand the process. Let's take the example of 3,000 times 4,000. Traditional math says to calculate the result by multiplying 4 times 3, which is 12, and then to count the total number of zeros in the initial multiplication terms and append them to this result. There are 3 zeros in each term, so the result is 12 with 6 zeros, which looks like this. Interpreting this result, it is 12 million, which we can also write with abbreviations and full unit names. And here is the calculation with no-zero multiplication. We have 3,000 times 4,000. 3 times 4 is 12. 1,000 times 1,000 is million. So the result is 12 million. So again, no-zero multiplication gives the same answer as long-form calculations. Another way to think about this is that we are multiplying 4,000 by 3,000. And multiplying by 3,000 can be accomplished by multiplying by 3 and then multiplying by 1,000. In long-form format, 4,000 looks like this. And if we multiply this by 3, the result is simply 12,000. And multiplying 12,000 by 1,000 will simply append 3 more zeros, which will make this result 12 million. If we look at the result from here over, these digits would be ones, tens, and hundreds, and these digits would be ones and tens of thousands. But since we have another group of 3 zeros, the 1 and 2 represent ones and tens of millions. So again, the next larger unit of magnitude. So again, the same numerical portion, but with the next larger unit of magnitude. But again, we don't even want to think in long-form format. we want to think in terms of no zero calculations. But the point is that no zero multiplication gives the same result as long form calculations. And you should practice with a bunch of numbers until you convince yourself that no zero multiplication will always give the same result as long form calculations, as long as you do the calculations correctly. Let's also look at the example of 800 million plus 400 million. We found that this was 1200 million. Again, because these have the same unit of magnitude, you can add the numerical portions and keep the same unit of magnitude. But since the numerical portion is above 1000, we need to resize this to 1.2 billion. Now we can write this calculation in long form format with all the zeros, and we would have this. This is 800 million, this is 400 million. Now to do this calculation, we add the digits in their place value. So 8 plus 4 is 12, so we carry the 1, and the answer looks like this. Now we have to interpret this result. This is 1,200 million, which is equivalent to 1.2 billion. Now you can see writing all the zeros here doesn't really add much value and just serves to keep track of the place value. Now we can keep track of the place value with the unit abbreviation M. And this encapsulates all the information from the zeros here or the place value of these digits. So that's the main point. No zero multiplication and no zero calculations more broadly give the same answer as long form calculations, but in a more convenient format that is easier to calculate with and to understand. You're not getting a different answer. You're getting the same answer in a simpler and more convenient fashion. So again, practice no zero calculations with a variety of different numbers and convince yourself that it will always give the same result as long form calculations. If you get different results, then you're not doing it correctly. So you want to practice that. Now we're going to do what I call a unit run. This is a great exercise to learn how to convert between the units of magnitude. I'll start with 1, and each subsequent line will be 10 times the previous value. And I'll convert to use unit abbreviations, so this won't use long form format. Again, the goal is to show you how to convert between the units of magnitude when doing calculations, for example, when multiplying and dividing numbers. So I start with 1, and then 1 times 10 is 10. 10 times 10 is 100. And at this point, I'm just appending a 0 to the prior value. Okay, 100 times 10 is 1000, which in long form format looks like this. But we want to write this with unit abbreviations. So we will write this as 1K with K for 1000. Okay, 1000 times 10, well, we can operate on the numerical portions. So we can multiply the numerical portion by 10, which appends a 0, which gives us 10. And the unit of magnitude stays the same at 1000. So this is 10,000. 10,000 times 10, again, multiply the numerical portion by 10. We have 100,000. Okay, 100,000 times 10. Again, we can operate on the numerical portion. So we can append a 0 to 100, which gives us 1,000. And the unit of magnitude stays at 1000. I'm going to write this value here. So 100,000 times 10 is 1,000 thousandths. But the numerical portion is 1000, so we want to resize to the next larger unit of million. So this is 1 million. 1,000 thousandths is 1 million. Okay, 1 million times 10 is 10 million. 10 million times 10, again, just multiply the numerical portion by 10. That's 100 million. And then 100 million times 10. Well, that's 1,000 million. But again, we're going to resize this to the next larger unit. And the unit sequence is 1,000 million billion trillion, KMBT, kick my big toe. So the next larger unit from million is billion. So this is 1 billion. 1 billion times 10 is 10 billion. 10 billion times 10 is 100 billion. And 100 billion times 10 is 1,000 billions, which again, we're going to resize to 1 trillion. 1 trillion times 10 is 10 trillion. Again, just append a 0 to the numerical portion. 10 trillion times 10 is 100 trillion. And 100 trillion times 10 is 1,000 trillions. We actually haven't discussed how to calculate with numbers larger than trillions. So this is something we'll discuss in subsequent fast math videos. Now take a minute to look at the values to recognize the pattern. You have 1, 10, and 100 of a unit before going to 1 of the next larger unit. And the process repeats. 1, 10, 100, then 1 of the next larger unit. So the numbers form a kind of pyramid. But the whole point is not to think in terms of zeros. and to help you do calculations with these units of magnitude directly, without writing out lots of zeros or converting to scientific notation. This is great for mental math and for business job interviews, like interviews in finance, consulting, and technology. The idea is to go from 100 million to 1 billion directly without going through the intermediate step of 1,000 millions. So if you have 200 million times 30, what's that? It's going to be 6 billion. Now, companies have revenues in the millions and billions. There aren't any companies with trillions of dollars of revenue yet. But there are companies with trillion-dollar valuations, such as Microsoft, Apple, and Google. Countries also have GDPs in the trillions of dollars. The US has a GDP of over $20 trillion, which the World Bank estimates at approximately $23 trillion. China has a GDP of over $15 trillion, which the World Bank estimates at over $17 trillion. Other countries have GDPs in the single-digit trillions of dollars. Germany has a GDP of about $4 trillion. India has a GDP of about $3 trillion. And the UK and France also have GDPs of about $3 trillion. And the entire US federal budget is approximately $3 trillion, or 3,000 billions of dollars. So for business, you generally don't need units of magnitude larger than trillion, as trillions reflects the value of the largest companies and the entire output of the largest countries. Now I'm going to do the same thing, starting with the number 2. So you'll get a sense for how things work with a different leading digit. So I start with 2, and each line is the prior line multiplied by 10. 2 times 10 is 20. 20 times 10 is 200. And 200 times 10 is 2,000, but we're going to write this with unit abbreviations, so we write 2K. 2,000 times 10 is 20,000. 20,000 times 10 is 200,000. 200,000 times 10 is 2 million. We're going to go directly to 2 million without writing down 2,000 thousands. 2 million times 10 is 20 million. 20 million times 10 is 200 million. And 200 million times 10 is 2 billion. 2 billion times 10 is 20 billion. 20 billion times 10 is 200 billion. And 200 billion times 10 is 2 trillion. 2 trillion times 10 is 20 trillion. 20 trillion times 10 is 200 trillion. And then 200 trillion times 10, well, that's 2,000 trillions. And again, we haven't discussed how to represent numbers like this. And again, we have 3 lines for a given unit, ones, tens, and hundreds of a given unit of magnitude before going to the next larger unit of magnitude. So this would be 2, 20, 200,000, then 220, 200 million, 220, 200 billion, 220, 200 trillion. And again, start off with 2, 20, and 200 with no unit of magnitude. So this is effectively no unit of magnitude here. Okay, now I'm going to do the same thing, but starting with 2.3 to introduce another significant digit to show you how we would represent numbers like this. So I'm going to start with 2.3. Now 2.3 times 10, we're going to move the decimal point. That's going to be 23. This is 2.3 times 10. We move the decimal point from here to here. Multiplying by 10 moves the decimal place 1 point to the right, so it goes from here to here, 2.3, and then we don't write it. Okay, 23 times 10 is going to be 230. We just append a 0 to 23. Okay, 230 times 10, well, in long form format, that's going to be 2,300. But we want to write this with units of magnitude and unit abbreviations. And this is clearly above 1,000, so we want to write this in thousands with the abbreviation K. So how do we do that? Well, we divide this value by 1,000, which moves the decimal place 3 places to the left. It starts here, and then where it's unwritten, and moves to here, here, and then here. So it becomes 2.3, and then we drop the trailing zeros. And then we use the unit abbreviation of K for 1,000. So this is 2.3 thousand. And that's how we would represent this number. And this is valid. If you multiply 2.3 by 1,000 and move the decimal place 3 places to the right, you get back 2,300 or 2,300. Okay, 2.3 thousand times 10, we're going to move the decimal place 1 point to the right, and we get 23,000. And then 23,000 times 10 is 230,000. Okay, now 230,000 times 10. Well, that's going to be 2,300,000. It's the same as this, but we actually have the unit of magnitude of 1,000. Now we want to resize this to millions, and so we're going to do the same thing. We're going to divide the numerical portion by 1,000. and promote the unit of magnitude to the next larger unit. So again, 2300 divided by 1000 is 2.3. And the unit of magnitude goes from 1000 to the next larger unit, a million. Okay, now you can start to see the pattern. 2.3 million times 10 is 23 million. 23 million times 10 is 230 million. Okay, 230 million times 10 is going to be 2300 million, which is going to be 2.3 billion. Okay, 2.3 billion times 10, 23 billion. 23 billion times 10, 230 billion. 230 billion times 10 is 2300 billion, which is 2.3 trillion. That's K. This is trillion. Okay, 2.3 trillion times 10, 23 trillion. 23 trillion times 10, 230 trillion. And 230 trillion times 10, again, we haven't discussed how to represent numbers like this. The main point is that this is how business people would write and say these values. Take 2.3 billion. This corresponds to 2,300 million. The 3 corresponds to 300 million. But business people wouldn't say it as 2,300 million. They would say it as 2.3 billion. And they would write it as 2.3 billion, either using a unit abbreviation like B or the full unit name. Again, they won't say it as 2,300 million. And you see this in financial newspapers like the Wall Street Journal, Financial Times, and other newspapers like the New York Times. You see, 4.2 billion or 3.4 million or whatever. You see decimals with millions and with units of magnitude. And we do it like this because with 2.3 billion, if 300 million were alone, we would just say it as 300 million. But since it is part of 2,300 million, the 300 million, we want to actually express that in billions because the largest value is in billions. So we want to express the 300 million in billions, and it's 0.3 billion. So we say the entire thing is 2.3 billion. And yes, if you multiply 2.3 by a billion, you will actually get this same value as 2,300 billion or 2,300 million. So again, the goal is to help you learn to calculate with units of magnitude and unit abbreviations directly when multiplying and dividing numbers. And again, this is great for business job interviews and for mental math and quantitative analysis in a business context. So I hope you enjoyed the unit run and the unit run 2, and follow for more fast math videos. This isn't the end of the story. There are many other concepts relevant to the material covered in this video, and here are topics of additional fast math videos I'm working on. First, comprehending millions and billions. I'll show you how to get a sense of scale for just how large millions, billions, and larger numbers actually are. I'll focus on applications in business and in real life. Second, I'll cover differences in numerical systems around the world. This will be helpful for non-English speakers and English speakers that work in international business. Third, I'll discuss methods for performing calculations with numbers larger than trillion. The unit abbreviations I outlined don't scale well past trillion and need some modifications. I'll discuss something I created called K notation, as well as scientific notation and other methods. To summarize, K notation represents numbers as a numerical portion times the power of K or 1,000. For example, 60 times K to the 4th. This is basically what no-zero multiplication uses, except no-zero multiplication has designated names and abbreviations for the first 4 powers of 1,000, which are 1,000, million, billion, and trillion. And this would be equivalent to 60 trillion, and you would read this as 60 times K to the 4th. K notation just extends this concept where the power of K can be any whole number. So instead of 4, you could have 5 or larger numbers. You could also write it like this with an explicit multiplication symbol. And I would read these as 60 times K to the 4th, or shorthand 60K to the 4th. I'll cover additional technical details regarding no-zero calculations, such as a formal analysis of adding and subtracting numbers with units of magnitude. And other topics, fundamentals of calculation. This would be a review of traditional addition, subtraction, and multiplication methods. These are important to understand, and a lot of people don't fully grasp these methods. Now, it's hard to fully understand where you are if you don't understand where you've been. People have been counting and calculating for thousands of years. You can't really understand the benefits of our current numerical calculation system and why it is the way it is, and identify areas for improving it, and even teach it effectively, without understanding the history of calculation and how people used to represent numbers, calculate numerical values, think about solving numerical problems, and even write how to solve numerical problems. So I think it's really important to understand the history of calculation and how numerical systems, calculation methodologies, mathematical notation, and even how mathematical calculations were thought about has evolved over time. And of course, I'll also have videos with additional fast math calculation methods that teach mental math and simpler ways to perform numerical calculations and solve practical quantitative problems. So please like the video if you did, and subscribe to the channel if you want to be notified about these new videos, and be sure to click the bell icon so you get all notifications. In addition, please share this video with friends who you think will want to learn no-zero multiplication or are interested in these topics. And if you want to explain no-zero multiplication directly to friends or colleagues, then please provide attribution to this video and to Fast Math. We also have a free online course for business math called Fast Mental Math for Business, and the basic version is free. This course teaches mental math and efficient calculation methods and covers the most important business calculation concepts and formulas, such as break-even analysis, market sizing, compound growth, investment decision criteria, and valuation methods. The calculation methods are taught with practical examples commonly arising in business, consulting, finance, and entrepreneurship, and the course covers quantitative interview preparation for these fields as well. If you work in business or want to work in business and are preparing for job interviews, or just want to understand how business people approach quantitative decision making, then you should sign up for this course. The basic version is free and includes all the calculation methods. We also offer a professional version which has extensive calculation drills and more detailed explanations, and has a 1-week free trial period. All material is available in a self-paced online course with on-demand video instruction that is accessible at any time and from any place with just an internet connection. Links for further information are in the description. If you want further practice on no-zero multiplication or want to learn no-zero division, then sign up for the 2-hour no-zero multiplication and division workshop. Any new calculation method or concept requires a significant amount of exposure to fully understand and extensive practice to fully master. This is a self-paced workshop that uses on-demand video instruction, like this video, to walk you through a simple step-by-step process to learn no-zero multiplication so that you will be able to use no-zero multiplication quickly and correctly for both mental and written calculations automatically without thinking about it. This is extremely valuable in business and in business job interviews. The 2-hour workshop also teaches no-zero division, which uses a similar method to divide by large numbers in a similar step-by-step manner. I start with the basics and build your skills incrementally. This course also provides a more detailed explanation of no-zero multiplication, so it covers more material than this video does. I also give you helpful mnemonics so that you can remember how to use no-zero multiplication and division. This course provides you with numerous calculation drills with guided solutions that you can print out and practice with pen and paper, which I think is the best way to learn no-zero multiplication. The workshop also includes interactive calculation drills, which are great for practicing mental calculations, so that you can fully master no-zero multiplication and division in only 2 hours. I invented no-zero multiplication, which is now being taught in leading business schools and consulting firms around the world. And these calculation drills are the drills I use to practice and master no-zero multiplication. All resources are provided in a self-paced, on-demand course that is available online at any time and from any place with just an internet connection. So if you want a more detailed explanation of no-zero multiplication, or if you understood the general concept but don't feel like you can use it naturally and want more practice, or you want to learn no-zero division, then sign up for the 2-hour no-zero multiplication and division workshop. Link is in the description. Thanks for watching. See you in the next video. And remember, keep calculating.